Okay, let's talk about car rentals. Probably going on a trip or something. To rent a full-size car, company charges $103.47 flat fee, in addition to 39 cents for each mile. In contrast, a researcher claims that the total cost of driving your own car, when you factor in gas, depreciation, and maintenance, is 63 cents per mile. Okay, so you have a car, they have a car, and then the end of the story is, what are you going to do? Are you going to rent one or are you going to take your own? So, number 1 says, write an equation representing the total cost of renting a car based on the number of miles you drive. And they've already given us variables, so that's nice. And I need us to remember, so I see that there's a constant rate of change for each mile, and there's an initial fee. So off to the side, I'm going to remind us that, what is it? If there's a constant change, we're a linear, and it goes, response is equal to the initial plus or minus, whatever. If it's increasing by a constant amount or decreasing by a constant amount, the constant ratio times the explanatory variable. Yeah. Okay, so just bringing back this constant rate of change, constant addition or constant subtraction. Okay, so because I feel like this is going to be linear, because we have a constant rate of change for each mile driven, and we have an initial value here. Okay, so here we go. The total cost, which is the response variable. Our cost is responding to the miles we drive, and the miles we drive is explaining how much we're spending. So total cost is equal to our initial fee plus 39 cents times however many miles we drive. Okay. And write an equation representing the total cost if you drive your own car. Okay. Well, there is no flat fee. You don't have to pay yourself a flat fee, but you will have to pay for gas, depreciation, and maintenance. So 63 cents per mile. Got it. Fill in the table of values to keep track of the total cost for each scenario. Okay. Well, zero's pretty easy. If you drive 0 miles to rent the car, you have this flat fee to deal with. Oh. Okay, I'm going to do this really quick. I can see this getting out of hand fast. Okay. Just to keep the space in check. Let's see if we drive 100 miles. Well, 39 cents a mile, 39 cents a mile for 100 miles. I believe that'll be 39 bucks. But, you know, never hurts to check. Okay, so 39 bucks in addition to this, $142.47. And now 100 more miles, let's tack on $39 more dollars. And we get $181.47. Let's do it again. We get $220.47. Let's do it again. $259.47 and an additional 100 miles. That would cost $289. I mean $298. Oh boy. Marker City. Okay. $298.47. Got it. Transpose my numbers there for a second. And if we drive 600 miles, $337.47. Okay, and that's for rental. Now let's go down and see how much it would cost if we own the car. So 63 cents per mile. And, well, multiply that by 100. So first of all, it would cost us nothing to drive nowhere. Drive for 100 miles, and that costs us 63 bucks. And an additional 100 miles, well, that would be 126, so an additional 63. And let's keep doing this. $189 to travel 300 miles. $252 to travel 400 miles. $315 to travel an additional 100 miles, and then 378 bucks is the cost if you're owning the car and you're taking your own car and you travel 600 miles. Okay, so just so that we see what's happening here, it looks like it's cheaper to own, or take your own, cheaper to take your own, and then cheaper to rent. So there's a breaking point somewhere here between 400 and 500 where it switches. So just so that, and I'm going to put in an inequality where, for what I'm talking about here. Okay, I like my pale purple. Let's see, so this, right, this is cheaper than that. Cheaper to use your own, still cheaper to use your own, but a $7 difference here. And then now all of a sudden it is cheaper to take the rental car, Okay, so there's a point at which it switches from taking your own to using the rental. Yeah? Switch. Okay. So let's take a peek at the next question. It says, find when it is cheaper to drive your own car versus taking the rental car. Okay, and it says round to the nearest mile. So I noticed that right off the bat because our table is in hundreds of miles. So when is it cheaper to drive your own? Okay, let's go back to this table. All of these, it was cheaper to drive your own. And then somewhere between 400 and 500, all of a sudden it became cheaper to rent. So I know that it's somewhere in between 400 and 500. So believe it or not, I'm just going to go halfway in between. I noticed that at 400, these are about $7 apart. And then how far apart are those? That's like 17 apart. So it's going to be closer to 400 than it is to 500 miles. So I'm going to go ahead and go with, I don't know, 440. 420? Should we go 420? Let's try 420. That's closer to 400 than it is to 500. So let's suppose for fun, we tack in to this table, and I'm just going to extend it down below. Why not? I have a black marker. Let's suppose we put in 420. Sorry. So 420 when it comes to the cost of renting. Okay. I put that into my calculator. I put 420 miles here, multiplied it, and then added the $103.47 flat fee. And I got $267 and no, I got 27 cents. Okay. Yeah, that makes sense. And then let's put that into how much it costs for your own. All right, I got $264.60. And now what I see is that it's still cheaper to take your own than it is to rent. So let's go a little bit higher. Let's go $430. But these only differ by about $3. So we're getting close. $430. All right. Oopsie. 63 cents, 430 of those. This would be $270.90. And the rental, so 430, 39 cents. So 39 cents charged 430 times plus the flat fee. I got $271.17. Let's see. Oh, look at how close those are. I mean, this is really, really close. This is not even $1 apart. It's like 27 cents or something, right? So let's just add one more because 27 cents, I mean, this is 63 cents. So, all right. Here we go. Yet another plugging away here. So flat fee plus 39 cents charged 431 times. The rental car would be $271.56, which makes sense. That is 39 more cents. Okay. And 63 more cents tacked on to this cost of $270.90, oopsie, plus 63 cents would be $271.53. Oh, so here, let's see. Okay, so it's just off by a smidge. Yeah? Okay, and then at 432, I bet you that's where it goes. Okay, this is a lot of like just compute. 272, 16 cents. And when it comes to the rental, I got $271.95. Yay, we found it. We finally found it. That's where it reversed. Right there. Okay. So, I mean, this is really, really close. This is really close. But this is where it finally reversed. And, okay, so, woo, that took a lot of work. So, find when it is cheaper to drive your own car versus taking a rental for the weekend trip. Well, okay, it was cheaper all the way up until 431 miles, and then it switched. So it was always cheaper to take your own car if it was 431 miles or lower. So, cheaper to take your own car. If the trip is 431 miles or less, take your own car. Yeah, it'll be cheaper. When would it be cheaper to take the rental car? On the flip side of that. So, okay, we'll go purple style, why not? Just keep the rental all purple here. If the trip is 432 miles or more, rent a car, it'll be cheaper. Okay. And that's just pure, like, financially based instead of something like, you want to take something fancy because you're on a vacation. Whatever. Anyway. So if the road trip is 431 miles or less, it'll be cheaper to take your car. If it's 432 miles or more, then renting a car will be cheaper. The inequality, okay, I see the flat fee. So I notice that this equation is identical to the rental equation. Okay. Flat fee plus 39 cents per mile is less than 63 cents per mile. And that is okay, so this means this is the renter less than the taking your own car. The inequality, renter less than take your own car, can be used to model one of the scenarios in number 4 or number 5. Cheaper to own or cheaper to take your own or cheaper to rent. Which one does it represent? If the rental cost is less than taking your own cost, this is number 5, when it would be cheaper to take the rental. So this is number 5. Where the rental is less cost. Solve the inequality. Right on. I mean, that whole guess and check thing and constantly putting it into the equation or into the calculator, boy, that's exhausting. So let's go ahead and take this inequality and solve it. My first step is going to be to subtract 39 hundredths m's from both sides, because remember that with the property of inequalities, if we add or subtract from both sides, add or subtract the same from both sides, the same inequality is true. So certainly we can subtract this many m's from both sides. So we would have same inequality, deduct this many m's. Well, we have 63 hundredths, take away 39 hundredths, we have 24 hundredths m's. Scale it down. I'm going to divide both sides by 0.24. It actually will scale it up just because we're scaling down by a portion, which is actually scaling up. Anyway, let's go ahead and divide both sides by 0.24. Okay, and notice that this is a positive. So because we're scaling by a positive, this is maintained, and we'll have an m here. 103.47 divided by 0.24 is 431.125 with no rounding. Solve the inequality. Done. Write what the answer means in the context of the situation. Okay, but remember, that's when it meant that the rental would be less cost or cheaper. So if the miles are greater than 431.125, then the rental will be cheaper. So if the trip is 431.125 miles or more, this says strictly more. If it was actually 431.125 miles, then they would be actually equal. So maybe I should have just put more than this many miles, whatever. If the trip is 431.125 miles or more, it is cheaper to rent. You know what's funny about this whole example is that a lot of our retirees actually go through this with in terms of keeping their homes or renting for the rest of their life. They're doing those quick analyses. So like, do I really want to mow? And would it be cheaper to... Anyway, nonetheless, solve this inequality. And I just got to say that it was much quicker to do this than it was to do all of these, right? So it is a benefit. Knowing how to solve an equation and solve an inequality has its perks. Okay, so let's practice that a little bit. Let's solve these contextless inequalities. All right. I look at this first one and I think to myself, I'm indifferent if you want to... A lot of my students will distribute this 3. My first instinct is actually to divide both sides by 3, because this would scale that. This is scaling it up by 3, and instead of tripling everything, we might as well scale everything down by 3. But I'm going to go with what the majority of my students would do naturally, which is distribute first. So 3 2x's will become 6x's. 3 9's will become 27. Okay, tripled. And I actually didn't do anything to this other side. I just rewrote that expression. But now I'm going to add 27 to both sides of this inequality, remembering that adding 27 does not change or reverse the inequality at all. So 6x is less than or equal to, what is that, 9? 9. And then I'm going to scale both sides down by 6. And because it's a positive 6, again, the inequality will stay the same. So, okay, and 9 6 can be simplified. That is 3 halves, right? Divide 9 by 3, we get 3. Divide 6 by 3, we get 2. Okay, so what is that, 1.5? Okay, so that means if you pick any value for x that is less than or equal to 1.5 and you put it in here, it will be true. So for these values, this will be true. Very similar to the fact that if the road trip was this many miles or more, then it was cheaper to rent. So if our, whatever it is, miles or whatever, satisfies this constraint, so if our x values are less than or equal to 1.5, then this original inequality will be true. Got it. Next. One down, on to the next. Oh, okay, well, there are some x's on this side and there are some x's on the other side, and I feel like we can combine those, but we have to move them. I'm going to go ahead and add. So this is negative, so I'm going to do the opposite and turn it positive style. So undoing that takeaway of 2 x's, I'm going to add 2 x's to both sides. That means I would have 7 is greater than 7x take away 14. Okay, I'm going to add 14 to both sides. Adding 14 does not reverse the inequality. So let's see, 7 plus 14, is that 21? Do not change the inequality. And now I'm going to scale down by 7. And because that's positive, again, I'm not going to reverse the inequality. 21 scaled down by 7 is 3. Now, I look at this, and it's a little bit tricky for me to read this, but this reads that 3 is greater than the x values, or x is less than 3. X values have to be less than 3. So if you want to rewrite this as this is true for x's that are less than 3, or 3 is greater than x values, or x is less than 3, however you want to write it, I feel like this is easier for me to read, but this is legit and correct. So that means when x values are less than 3, this original inequality will be true. For instance, 0. We could try this. If we test x equals 0, we'll have 7 greater than negative 14. Definitely true. All right. Let's do this. I'm going to distribute. I see that we have some parentheses. Let's quadruple. For x, so quadruple your x, then you'll have four of them. Quadruple your 2, and you'll have 8. And now it appears that we have 4 x's in addition to 2 x's on the left side of this. So really there are 6 x's over there. So I'm going to go ahead and put them together because it's weird that they weren't together. Oh, here we go. So now there are 6 x's on both sides, so there's a balance of however many x's are on each side of this equation. And so I'm going to deduct 6x from both sides. And that does not reverse the inequality because it's subtraction. And it would read, so take away the 6 x's and we would have negative 8. Take away these 6 x's and we would have 10. It says negative 8 is greater than or equal to to 10. That is just never true. And that is the answer to this problem. So it doesn't matter what x value you put into this inequality, it will never be true for any x values. For any values of x, it won't be true. For instance, if we put in 0, well, this would be negative 2. 4 times negative 2 is negative 8 plus nothing. Negative 8 greater than or equal to 10. Nope. And what if we put in 2 for x, right? Then we would have 2 take away 2 is 0, so this whole thing would be 0. 2 by 2 is 4, and that would read 4 is greater than or equal to, what, 12 plus 10? Yeah, that's not true. So this is just never true. It doesn't matter what x value you try, it'll never work out. Okay, so it's never true for any x values, regardless of the x values. So a couple of quick remarks as we kind of package all of this together. Solving inequalities is similar to solving equations. The steps are very similar. There's only one little snafu. So solving inequalities is very similar to solving equations. Okay, we just have to remember to reverse the sign if we multiply or divide by a negative. Just remember to reverse the sign, or the inequality symbol. Maybe I should have written inequality. When multiplying or dividing by negative numbers. Okay, and then I have one more remark, and that is that one difference between solving equations and solving inequalities is that in the end we end up with an inequality, and that means that we have many, many answers. When we were solving the equations, we would end up with x equals some number. So it would be like one thing that works in the inequality. But here, this is really indicating that there are many things that will work in this original inequality. So solutions to inequalities typically or likely end up including many values for x. or the explanatory variable. And here's what I mean. If we go back to the miles, right? I mean, we were putting this in, and there were many values of miles driven that had one be cheaper, and then there were many miles when the reverse was cheaper. So, so it is possible for these inequalities to be true for many different values of the explanatory variable. In this situation was miles. In this situation it was X because it didn't have a context. But still, just wanted to, put that out there, that is one difference between solving equations and inequalities. So what we just got done doing is actually solving linear inequalities in one variable. And we described what the solution means in the context of a situation. Okay, so the one thing that I just want to make sure that we remember is that it is very similar to solving equations, but remember to reverse the sign, or remember to reverse the inequality when multiplying or dividing by negatives.